All right, everybody. Thank you for joining us today. My name is Brittany Dufilly. I'm the Educational and Outreach Coordinator here at Vertex. We've got a great presentation today and some great presenters from Datto. Today, our focus is going to be on the recovery process of business continuity and disaster recovery. Obviously, with most of us being in Florida, we have to have that issue with storms and electrical outages and everything else. So our presenter here today, Dan, is going to be showing everybody kind of what the Datto Cirrus can do. So with that, Dan, it is all yours.
Thank you, Brittany, and a pleasure to be presenting on behalf of Vertex and the Datto solution today. Just a bit of background in myself. I'm a solutions engineer with Datto. I've been here for almost 10 years. If you count back to my first week, that's Superstorm Sandy here on the East Coast. And for a company based in Southern Connecticut, you can imagine it's a very, very interesting time to join this team when the sole solution that we had was Cirrus and business continuity, disaster recovery. I'll use that as a nice anecdote when we talk about running systems in Datto Cloud where necessary a little bit later on. Prior to working here, I do have an additional 12 years of IT experience, and I got to be perfectly honest, I never dreamed I would be working in the backup space. I never liked backup technology. It always seemed to fail me when I needed it the most. There's not much assurance that things are working properly, and testing should be done, and it's never done to the degree that it should be. And you know, I'm only speaking from personal experience. I'm doing things for my friends and family back then. Working for this company and realizing what this solution offers, I quickly realized that this is not just a backup system. And the amount of information that it provides and our ability to be proactive about troubleshooting, that's really my favorite thing. We will talk significantly about this advanced backup verification process. We'll walk through setup and deployment, how simple it is to get things going. But after it's set up, it's really just a matter of monitoring it, and that's going to be handled from the Vertex side of the house. Immutable storage is going to be another huge topic of discussion. This will go hand in hand with the security of the solution overall. And then, of course, we're going to talk about how to recover data, whether it be a file restore or if a system were to fail. I'll give you a nice 30,000-foot overview. Cirrus is a hardware appliance that's meant to reside within your infrastructure alongside of your servers. And it takes image-based backups. I'll describe how this capture happens. It stores the data in a very particular fashion. We developed our own method for backup storage, part of what's so cool about this solution. And in that fashion, if a server were to die on your side of the house, I mean, talking hardware failure, software failure, ransomware, what have you, within a matter of seconds, we can boot from any backup that we've taken a virtual copy right into the Cirrus hypervisor or back to a virtual environment if you happen to be leveraging Hyper-V or Vmware, and get you back up and running within a relatively short amount of time. Literally how long it would take to boot the system, reassign an IP address, reboot one more time, that's it, you're back up and running, and you can leverage the virtual copy for really however long you need to, and then we'll talk about methods of failing back. Beyond that local appliance, Datto has private cloud infrastructure in both Pennsylvania and Utah. Actually, we have data centers all over the world today, but for our stateside partners, everything tends to reside in the US. And where there would be an instance where you couldn't work from the original location, call it extended power outage or perhaps something a bit more detrimental, we can launch your entire network in our cloud in less than 24 hours. That's always been our tagline. That typically happens in well under that time. I'll describe a bit more about DR testing, but now you can leverage and work on your network in our cloud, and there's some really cool things to talk about in terms of a flat rate for being able to do so. A lot of times when you're offered that type of failover, companies would look to charge you for CPU and RAM or how much data you're storing in their cloud, and they tend to have variable costs. I think one of the neatest things here is that we've built this model to be flat rate. So you can run and work in our cloud for a period of time, and then we'll talk about how to transition out of the cloud if that were to happen. But let's take a giant step backwards and take a look at the interfaces that we use to control the system. So you can imagine Cirrus, this hardware appliance, it ranges from 2 terabytes out to 60. I'll talk about how to size it appropriately for hard drive space and RAM a little bit later on. And the only thing that we're plugging into that system is CPU and RAM. And this is the web interface that we use to control that device. And we'll talk about how to access this. Within the Datto Partner Portal, under status and BCDR status, an acronym I want everyone to be familiar with, that's Business Continuity Disaster Recovery Status, Vertex can view all of the systems deployed within their fleet. And not only can they monitor from here, this is the primary means of accessing that system. This portal has multi-factor authentication, so no one gets in here without authenticating themselves. Secondly, any action taken by anyone is completely logged, and a level of access can be granted not only to the employees there, but of course to the clients as well. So we can, for anyone that wants to be able to get in here, monitor and manage their solution, this can be co-managed as well. When I first started working here, you could take this system IP address and target it in a web browser and log in with a local user account. And while we can re-enable access to do so, that's actually disabled by default today. The primary means of accessing the system is by clicking Device Web. As another security measure, if we had re-enabled that local account, there's no way of removing data if you log in local. The only way of removing data is by remoting in, and let's say this action had been taken. Just a part of the security and the immutability of the solution overall. We're going to review this blog here in a moment. Let's say someone had come in here and literally tried to remove agent data by deleting data locally in the cloud, and it says this process is irreversible. That's actually a bit of a fib. A number of months back, we introduced a feature called Cloud Deletion Defense, where if this action had been taken within a certain set period of time, we can actually undelete the data. You can think of this as a recycle bin feature for our cloud. When we talk about the overall immutability of the solution, security of your data overall, there is one major point to make here. This system is Linux-based and sitting on a very special file system. For those of you that have heard of ZFS, the Zettabyte file system, you may be familiar with some of its built-in capabilities. So this is a Linux-based system. We talk about ransomware right off the bat. The majority of ransomware ran from Windows. That's not the end all be all, but this file system does provide a number of different things that are absolutely incredible. We're going to talk about data capture, but in terms of data storage, we'll reference our snapshotting capability within this file system. When we talk about data security for recovery, we're always making a clone of our data set. We'll talk about how quickly these can be made with this file system as well. And one of the most important characteristics of the file system is data integrity. I love showing off this paragraph right here. So this file system includes end-to-end checksums, data authentication at multiple levels. It excels at data integrity by detecting and addressing silent corruption scenarios, phantom writes, so on and so forth. But the net, and really the most important thing to tell you about where your backups would live within this appliance, and the entirety of Datto's cloud infrastructure being built on ZFS as well, is that it cannot be corrupted by ransomware. Please do not take that as gospel. Please do your own research in this file system. It is very, very cool to start unpacking everything about this under the hood. The backups are also stored in a read-only format, really cool technology under the hood, which we refer to as inverse chain technology. We're going to review more about that in a moment. This blog, again, is accessible right in the chat window, or Brittany, wherever you drop that in there for them to log in and take a peek at this in more detail.
Yep, there's the two that you're going to be discussing are right in the chat window, and I will send it out to everybody as well that it was on the webinar.
Awesome. Setup and deployment of something like this is relatively simple. We're connecting the device to the network, but prior to the device arriving, we can actually do the good majority of work that we want to make sure that the servers are healthy and clean, right? Check disk, defrag, virus scan, make sure your images are nice and healthy as they come in, garbage in and garbage out in terms of recovery. And then there's two different ways of protecting systems, but both offer an image-based backup. We'll go into more detail about this capture method. Traditionally, we're installing software. A very lightweight agent from our download page can be installed directly into physical servers or virtual machines. We have compatibility with Windows dating back to, Server 2003. We still support here with our legacy agents all the way through the most current iterations of Windows. And we do have a Linux agent as well. Compatibility there is going to vary from different distributions. If you happen to be working in a licensed VMware environment, we don't have to necessarily install software. We have integration with the host server where we can just back up via the host API agentlessly. And the neat thing about that is we don't care about OSs here for agentless backups. We're completely OS agnostic. So we can back up vCenter itself. We can back up anything that lives in VMware. Either method would allow an additional layer of security as well. As we add in systems for protection, we can actually encrypt them completely via a passphrase that Datto does not manage. That would be managed between you and Vertex. That passphrase is required to do recovery. So there's the first major consideration is don't lose that passphrase. You'd have to delete everything and start over from scratch if that were lost. But this would affect our sizing methodology a bit. Traditionally, in order to make sure you have enough hard drive space here in our system, we look at the consumption amongst the systems you're looking to protect in the individual volumes, the C drive, the D drive. Used hard drive space is typically multiplied by a factor of about 2.5 to 3 to dictate how large of an appliance you need. If you're going to be encrypting your systems, it makes more sense to lean times 3x. So if you had about a terabyte of consumption, you'd probably be looking at a 3 terabyte solution from our side of the house. As those systems are added in for protection, we can initialize backup manually whenever we want, but of course we're also looking to do things based on a schedule. And in terms of scheduling backups, we're going to be a bit more consistent than what you might be used to. Traditional backup software tends to impact the performance of systems pretty significantly. When we take a look at what's happening under the hood with legacy backup software, that software traditionally has to traverse the entire hard drive and any volume being protected every single time a backup's requested, which slows down the disk significantly. That's why people tend to only backup once per day at the end of the day when no one's working. This solution was built for consistent protection. Our minimum recommendation is to back up every hour on the hour, and our shortest interval is every 5 minutes. You can see this one's backing up every 10, this one's every hour, 15. So we can stagger our intervals and pay attention to that capture. Now, the initial capture is everything. Every bit of data on any volume selected for protection will be compressed as it's brought over here. And the subsequent backups are application aware. We integrate with the volume shadow copy service within Windows. So if you happen to be running your own Exchange database or SQL, we're able and meant to back up those databases consistently throughout the course of the day. And then the most important feature to understand here is the block level concept. We do not go through the entire hard drive every single time a backup's requested. When our agent is deployed, there's a very lightweight software at the kernel level being deployed, a block level tracker. This is before the operating system even loads within the system. And that little driver software actively tracks and monitors the blocks that are changing on the drive. The easiest way to think about this is we don't go through the entire drive every time a backup's requested. We go through it once and then we're smart enough to pick up where we had left off. And what does that all translate to? We're going to take backups at least every hour on the hour. Not going to lose more than an hour's worth of work. And furthermore, you're not going to notice that our backups are running. It should have very little impact in terms of server performance overall. Zeros can also protect workstations. As a matter of fact, I'm backing up a Windows 10 box right here. If they are systems that are moving, like laptops, remote systems, we have different solutions. This is really built to protect local infrastructure. How this data is stored is really the key to what makes Cirrus Cirrus. It's called inverse chain technology, and it is incredibly different from an incremental chain. I think an incremental chain is really what gave me all of my disdain from backups in the first place. The major difference is that with traditional backup software, you take a full image, and you can continue taking full images, but you're consuming a lot of storage, and it's very difficult to get that full image every night to another location. Or you can go the route of taking full and incremental backups and differentials. The problem with that technology is that backup A relies on B, relies on C, and within that, if there's any incremental corruption, you can't restore beyond that point in time. The backups rely on one another. And when do we tend to find out that we have incremental corruption? When do we find out that our backups are broken? At the worst possible time, usually after systems have failed and when we're in the middle of recovery. If you think about it this way, what are we traditionally told when a backup completes? That it's copied from point A to point B, and that's pretty much it. What does that tell me about recoverability? Nothing. And therefore, we should be testing. Now, to what degree do we really test our backups? How often does that happen? When I ask this question of people, I get the funniest answers, very scary answers, but pretty funny. We don't do it at all. Perhaps we do a file restore every once in a while. That still doesn't tell you anything about full image recovery. Or maybe we do something once per year in terms of restore. The degree of automated testing and verification that's happening here is absolutely incredible. But first, let's describe how these backups are stored, leveraging this very special file system. So the first thing to understand about ZFS is that it was developed to handle massive amounts of data. That should be relatively obvious for anyone that understands how large one zettabyte is. the zettabyte file system. 1 zettabyte is enough storage to hold 30 billion 4K movies. Another point of reference, the entire internet is approximately 40 zettabytes. It was designed to work with massive amounts of data. It's super fast. I can't wait to show off some of the speed in terms of restore here in a moment. It has a cloning capability. We'll talk about that in terms of peace of mind when we do recovery. We never touch the image itself. We may always make a clone of it, but most importantly, this snapshotting capability, which is relatively similar to taking a snapshot of a virtual machine. So here's how our technology works. We make an exact copy of any volume selected for protection on your side of the house, the C drive, the D drive, the E drive. As that copy comes into the system, it's stripped of its hardware identity. So I don't really care if you have a physical server, if you're running Dell, HP, if you're using VMware, Hyper-V, hyper-converged solutions makes little difference to us. We can recover to all of those environments. As that drive comes into our system, it's converted into a virtual hard drive that we then snapshot using our file system. Now, what are the benefits of that? The first benefit is that while we're only capturing what appears to be incremental data, our backups are completely independent of one another. There is no chain dependency. We'll talk about how we can delete them. The deletion happens on the appliance after about 3 months. The device is designed to hold 3 months worth of recovery points, and that's it. It automatically deletes beyond that point. That period of retention can be adjusted on the appliance. The majority of your retention will be held in Datto Cloud. Now, a while back, I'm thinking maybe 7 years ago now, we developed a really cool concept for our cloud storage. Traditionally, when you're talking to a backup vendor, they're going to charge you for storage, and the more you consume, the more you eat, the more you have to pay in some convoluted variable price per gig model or price per terabyte model. We have that plan. No one uses it because we introduced to the world a concept called time-based retention, where we can hold the data in the cloud for a year, 7 years, or indefinitely at a fixed rate. We don't care about how much storage you consume in our cloud. We have plenty of storage to go around. A number of years back, about 2 years ago now, we exceeded an exabyte of storage in Datto Cloud. Plenty to go around. The other benefit of being able to delete these recovery points, they exist independently of one another. So we'll talk about how if one is broken, we've been made aware of that, but we can actually delete it without breaking the chain. There is no chain of backups here. Now, most importantly, we used to use an incremental chain within the solution. And let's say a server of just 200 gigs had failed, and we needed to fail over. That's our major concept, right? We're built to get you back up and running. A server of just 200 gig in size would take us approximately 24 hours to virtualize. You can picture the process. We had to compile all of these little incrementals, combine them with the base image, and then convert that into a virtual hard drive, which meant the more data you had, the longer it would take. 200 gigs in 24 hours, it doesn't make any sense. You can restore 200 gigs in a much faster amount of time. The major benefit of this technology is that that operation happens in 6 seconds flat, despite the size of the server, the number of backups recorded, or moving backwards in time. So we don't care if you have 50 gigs, 500 gigs, 5 terabytes worth of data, you can expect that that image will virtualize in about 6 seconds flat. Given the speed at which that occurs, we started building our first proactive automated verification features. It was born with a feature called screenshot verification, a very simple process whereby on a daily basis, after the backup is recorded, we tell Cirrus to actually boot a copy of the production server. It emails the report to whoever is outlined, and we can also keep an eye on that process from here. I wrote a blog about this concept. This is literally my favorite thing about the solution. I love the title of my blog. I think it's very funny to me when I read it out loud. Why managed service providers should be proactively troubleshooting your backups. Why? Because we can. When have we ever been proactive about backup troubleshooting? Is it not always incredibly reactive to the failure we're dealing with? We can stay out in front of our issues. That's the coolest thing here. So beyond screenshot verification, there are 7 additional layers, but let's just start with a screenshot and what this tells us. So imagine on a daily basis, if we're seeing success, which is login, we don't have to do anything. This is simply the system telling us that if you need to fail over, we're not going to have any problem in starting Windows. Much more importantly, this process will proactively recognize a non-bootable image as anything other than login. Think blue screen of death, startup repair screen, new sad face of death, whatever the new Microsoft method is of telling us that we can't boot. If we've been made aware that we cannot start Windows as step one, then we know that you can't fail over. So let's talk about troubleshooting that. It's pretty cool. Let's say for this server, I've received notification that the screenshot had failed. So I'm not looking at login here, I'm looking at one of the other instances. There's only a number of things that can be wrong. There's something up with our software, there's something up with your server, or something up with Cirrus itself. So Vertex, either on their own or using our tech support as a third party behind them, we have 24/7 support for the solution, addresses and fixes the issue. They take the next backup manually and verify that this image can boot successfully. We can either run a screenshot here, or we can actually take any of these points and launch them into a virtual environment segmented from the network in a sandbox. As soon as we verify that we're good moving forward, picture that any of these recovery points can be deleted absolutely free of consequence. They're not really incremental backups. They're more like snapshots of a virtual copy of your production machine. And for anyone that's technical on the line, you know, if we deleted incrementals with a traditional chain, this would be the last backup that we could restore from. These would all be useless, and not only that, we'd have to take another full image. Not the case with Cirrus. As a matter of fact, we're going to do all of our restores from the 22 system, and we can restore from above, in between, below points of deletion, no problem. There's no chain in this system. And for me, right there, I would never use traditional chain-based technology ever again. Now, if that were the only thing that we were checking, okay, pretty cool. Definitely. If we can't boot, we can't do anything. But does seeing a login screen really tell us anything about running an entire server and its applications? And the answer is no. No, of course not, right? We need to be provided much more information, which is why we developed these 7 additional layers of automated verification. Screenshotting has been significantly enhanced. What would only test at the operating system it started in the past, about 10 years ago when this was developed, will now check that these Microsoft applications have started correctly by toggling them on. So say we're verifying SQL Server, DHCP, Active Directory, DNS, we just toggle this on, pretty cool. Pretty standard Microsoft applications. More impressively, right below that, every single service from that server is dropped into this list here. This is not an arbitrary list of services. We can verify that any other essential service of that system had started correctly. Last but not least, a PowerShell script can be uploaded here that can verify additional information, that SQL has the right number of tables, that you can get to a particular web application, that services on delayed start had started correctly. And those all tend to run once per day per system being protected. Advanced screenshot verification. In addition to that, remember, this is not our grandfather's backup solution. We don't back up once per day. We're looking to back up consistently, at least hourly throughout the course of the day, whenever data is changing. When every single backup completes, we're doing the equivalent of a file system integrity check on the C drive, another check just to make sure that the volumes that are selected for protection are actually present within every backup that we take, and that the volume shadow copy writers are healthy within that system. Remember, we're an application-aware backup engine. We integrate with VSS. If there's an issue with VSS, we have a crash state fallback, so the backups continue while we fix what's up with the volume shadow copy writers on that side of the house. Last but certainly not least, in terms of the consistent checking and local verification, when every single backup finishes, we have tests that are designed to pick up on the early stages and signs of ransomware. This is a post-encryption notification. Your system, unfortunately, at this point is already encrypted. When a system is encrypted with ransomware, there's a massive amount of data change that happens within the file system. I hope nobody's seen this before, but if you have, every single extension changes, and that's basically what we're picking up on. Not only would this trigger one of our warning notice emails that says, hey, get that server offline before it spreads all over the place. More importantly, this feature will reactively mark any backup suspected of having ransomware within the interface. So as we go to recover at a file level or virtualize the system, in bold red lettering right here, it would say ransomware suspected. For me, that's half the battle. Now I can move backwards in time prior to encryption. Not the end all be all. I'll talk to you much more about what it would look like to fully recover from ransomware, but at least we can quickly identify where the file system is not encrypted. Think about traditional backup and encrypting or backing up an encrypted system. How would you know which image to recover from? It would be very difficult. Imagine going through an entire restore scenario only to realize that you had restored encrypted data and then we have to start over. At this point, if you would, combine those 8 features together into what we call advanced backup verification. I've literally never seen a solution on the planet that provides this much information in terms of what happens when a backup finishes. It allows for a much more proactive approach to troubleshooting and really means that we can stay out in front of our problems. The other big consideration here is that we don't have to worry about the cloud side of the house. Normally, these things might be segmented. Here's what I mean by that. Sometimes you have somebody's backup software sitting on somebody else's hardware going out to somebody else's cloud. And when things go wrong, these vendors love to point fingers at one another in terms of why things aren't working. This is our hardware, it's our software, it's our cloud infrastructure. The cloud infrastructure mirrors the technology here. So while all of this verification is happening on the appliance, remember, it applies to our offsite data. Furthermore, we get to test things in Datto Cloud. If we head into the recovery launchpad, the device only holds 3 months worth of recovery points. Well, maybe I need to do a file restore from 6 months ago or 6 years ago. No problem. Not only would Vertex have access to this, but anyone with access to our portal can come in and do a file restore in our cloud. I'll show you how this works a bit later on. You can actually virtualize systems in our data center on your own. Or in a truer test, as often as quarterly, we can request to work with Datto support and segment from network, but at least we can build the network in our cloud, document everything that we need to understand about disaster. This way we're not going into it blind. The other cool consideration is just getting data to our cloud in the first place. Remember, with the lack of a chain-based technology, the full images need to go to the data center initially. We typically seed them with a process called round tripping. This is a drive connected to Cirrus. It's either a USB drive or a NAS, depending on how much data we're talking about. So we drop the images from your system into the appliance. Replication is turned off. We copy the lion's share of the data onto removable media and just ship that right to the cloud. After the seeding is complete, when we reinitialize replication, the first thing that we can do is throttle bandwidth. So during the busier hours of operation, we tell the system to use a subset, a fraction of your upload speed, and perhaps after hours we're using the full capacity of the pipe, or maybe 80 to 90%. Take a look at the minimum bandwidth requirement for the solution. It always makes me laugh. 1 megabit of upload per terabyte of storage? How is that possible? The very simple fact that we're not dropping new full images and replicating them to avoid too long of a chain. We actively track the rate of change occurring within the network. This is a demo environment, so I only have about 15 gigs of change, but we're looking to monitor that the daily rate of change is consistently smaller than what the system can replicate after we've throttled bandwidth. And you can see how much I'm able to replicate with 50 and 25 here. I can get almost a half terabyte over the weekend, a little bit more than that, almost 400 gig throughout the course of the week. It does not take much bandwidth to get data into our cloud. It's not going to be a tremendous strain on your network. Really, from your perspective, you shouldn't notice that this is running and working the way it was designed to. Replication to our cloud is default daily. However, when this value is significantly smaller than what we can push, we can achieve this beautiful, consistent replication policy. I love showing this off. Really what this is saying is that we're not going to lose more than an hour's worth of work no matter what happens. Compare that to a daily backup, right? Where if something went wrong, you might have to revert back to yesterday. It's a whole day's worth of work. With that, Brittany, I'll just double check any questions so far, because we're going to get into recovery and we're about halfway through. So
Nope, not yet. Anybody if you do have any questions, go ahead and throw them in the chat window.
Sure. We're going to get into restore next. This is really the nuts and bolts of the solution. How quickly can we recover data? We're going to start with file restores, and we'll use that 22 system that I deleted some of the backups from before. If someone had accidentally or maliciously deleted data and we needed to recover it at a file level, we have a number of different ways of doing it. The key to this is that it's always a clone of the data that we're working on. We're going to reference this zero copy writable cloning capability of our file system. When I first started working here, our former CEO and founder and the young man that developed this technology, his name is Austin McCord, I was picking his brain. I said, Austin, why do backups tend to break while we're using them? Well, where does this come from? And he said, Dan, you would be absolutely amazed to find out how many even modern technologies do restore from the image itself. And the more you touch that image, whether you're testing recovery, doing actual restores, or back in the day when we had to swap out our storage and be very hands-on with our backups, the more you touch it, the greater the risk is for corruption. It's absolutely unbelievable. The more we use the solution, the greater risk there is for incremental corruption, breaking backups, and not being able to fully restore. So the simple fact that we're taking a very small backup and combining it with a clone of this system should leave us with a lot of peace of mind. Now, granted, this is just an operating system, not a very large image, but expect relatively similar performance when we're dealing with larger data sets. Here's how long it takes to mount an image for file restore. Please do not blink, because it's finished. That's it. It's done. There's the entire protected drive. Mind you, this is a web page as well. I can now browse, I can search, and I can click and download the data right back into the original system. Any folder would be compressed and zipped up as we download, or a file is literally a click and a download away. While that's simple enough, we've had to make modifications. We've had to develop different things here to overcome certain issues. One of those issues was that NTFS permissions are not retained. We're Linux talking to Windows. To overcome that, we can present the protected volume, not just over NFS. This is a window share, so we could have actually just gone into File Explorer and browsed that way. We can present the protected volume via Iscsi back to the target machine on the network. We can do so with enhanced authentication with a handshake if we want to. We're not going to do that for the demo. I'll just generate the target. Okay, that's done. Every Windows-based system has this little program built into it called the Iscsi Initiator. And what we're going to do is target my Cirrus's IP address. In my case, that's 10.32.16. Connect to our target. And once I do, you'll notice that a new logical volume is about to populate. Ah, there it is. That D drive is actually this server C drive. And now with a utility within command prompt called robocopy, we can get data from here to here with NTFS permissions intact. Heck, we could have copied all of our data. That might be a full restore utility. That was very common in the early days of the solution, to be made aware of a significant issue and then for us to retroactively go back and develop new things. Another one of those problems was not knowing when the data was deleted. And that posed a very significant issue. What our early partners were stuck doing was, and you might be familiar with this yourselves, mount search, mount search, mount search, mount search. What a nightmare. Trying to aimlessly find something when you didn't know when it were deleted, bit of a problem. We developed backup insights as a result of that. This is incredibly impressive, and it's just ZFS going to work again. Rather than searching amongst all of the images, we can compare two. And this utility allows us to do way more than just locate lost data. Very cool. So I'm just going to compare the last backup I took today for the server with the one that I dropped back in April. The earliest and latest points in time, for lack of a better description. Initializing, we've already mounted both images, or a clone of them, I should say. Calculating the differences between them, this will literally show us any block level change that had occurred between them. And that operation is complete. What we're going to do is expand our folder structure. And in that very short amount of time, not sure if anyone counted how long that actually took, but what we can see is anything that were modified, deleted, or added between the recovery points. If you can see the size of my scroll bar here, modification was up at the top, that was yellow, addition is green, and then deletion is red. Now, if I'm looking for something here, given that this is a web page, I can just Control F and find what I'm looking for and say, oh, well, yeah, there's what I'm looking for. There's where it was deleted. Here's where it used to exist in that earlier image. And now I can just click and download from here. But if you consider your other use cases, maybe a drive filled up, maybe we're assessing where growth had come from. Maybe I'm looking for something prior to modification. Here's an earlier version. Or in a ransomware scenario, one of the first steps that we would take to assess where we're healthy is to say, oh yeah, we're encrypted here, here's where we're not encrypted. I love this utility. It comes in handy for so many different scenarios. And there's one more really cool thing to talk about in regards to the engine that this uses to do the comparison. For those of you that are familiar with shadow copies in previous versions, they're usually enabled on laptops, desktop type systems. We've built a rollback utility into our recovery environment. Let's say Windows is broken. Let's say a relatively small system under 1 terabyte is encrypted with ransomware, and we don't want to format the system. We just want to roll it backwards in time. We can do that relatively quickly. This is our full recovery environment. It's what we used to do a full bare metal restore. Imagine a system had failed over to the Datto appliance, and now we're looking to fully restore to another system. This is the utility that we boot from. When we boot from this utility, our rollback utility is in there as well. So we're going to browse. I've already loaded that utility into a virtual machine. So we're browsing to its IP address. It always checks for updates and driver packages, meaning that this is a true bare metal restore. If you had a Dell and you wanted to move to an HP, if you have Intel and you want to move to AMD, we can do that no problem. We're hardware agnostic in our recovery. But that type of restore can take some time. Rapid rollback is fast, hence it's a very clever name. So what we do is we load the original system into this environment, bypassing Windows. We select the affected machine, the point that we've already identified as healthy, and what I really love about this is our ability to select individual volumes. Think about Windows being broken on a very large system. Why would I recover the data volume when all I'm looking to do is fix Windows? Why would I use the Windows recovery environment utilities when you try one, it doesn't work, try another one, it doesn't work? Here, we simply just select the C drive, roll it backwards in time. It doesn't format. It uses ZFS to assess hundreds, if not thousands of changes within a matter of seconds and minutes. Rapid rollback, really cool technology there. One more little nugget before we talk about the failover concepts, both locally and in the cloud, and that is our partnership and our granular recovery capability for Exchange, Sharepoint, and SQL. Now, for those of you that have already moved to the cloud with these applications, that's not going to help us. We have separate platforms that can protect Office 365 and G Suite. It is a bit of a rarity to have local Exchange or SharePoint, but SQL certainly does stay in-house. And what this software, Curl On-Track Power Controls, offers for SQL is just absolutely incredible. If anyone's ever experienced table-level corruption or deletion and how to use the built-in Microsoft recovery process, SQL has its own built-in backup and restore. It's very painful. You're not doing this for a good time on the weekend. You have to turn off your database in order to do it, and you don't have to do that here. As a quick example of what that looks like, we're going to head into our knowledge base. And let's see if I can pull up that article pretty quickly for us. Curl and SQL. By the way, this is a public-facing website. And here's a bit of detail on how that program works. The nice thing is it's included with the solution. There's an executable and license file, no additional charges for that. We get the program, connect to the database, mount an earlier point in time. It mounts as a network share. And so in this case, the 10.151.215 is Cirrus. We're going to connect to that target. And here's the magic down below. Once the backup has been mounted, I can click on an individual table within the database, verify it's the right information. Let me blow this up so everyone can see it, and literally drag that into a SQL database and copy without having to turn things off or without having to fully restore the entire database. So for those of you running SQL, that can be a bit of a time saver, lifesaver there. Okay, the major concept. Let's picture that the most mission critical system within your infrastructure died for whatever reason. Backups are failing. Perhaps Vertex makes you aware that this has happened proactively. Pretty cool concept for a backup solution. Hey, this system is meant to check in, every 10 minutes or so. And those alerts in the status page come through very quickly, especially if we're consistently protecting. So backups are failing, email notifications are being sent out. We're being made well aware that there's a potential problem, and this is what it would look like to return an individual system back to production. In that case, we would likely spin up the copy of the production machine on Cirrus itself. I'll describe these other options here in a moment. If we needed to move backwards in time prior to ransomware striking the system, we have some really cool features as well. So let's say in our case, we've identified that the system was healthy, or not encrypted, I should say at 6:57 a.m. Moving backwards in time has no impact on the time that it takes to start a copy of the production machine. It can with other solutions, that's why I mention it here. The CPU and RAM available in Cirrus is completely customizable, and I will also note that we're into our 5th generation of hardware. Very, very cool stuff happening under the hood. For those of you that would like to see some hardware specifications, Brittany, we can send the sheet along, but we can customize hardware. Every system is completely custom built to meet the needs of the environment.
Yeah, absolutely. And I can attach that to everybody's email when we send it out this afternoon.
Very good. In starting the copy of the production machine locally within our built-in hypervisor, which by the way is KVM under the hood, we can do so disconnected from the network completely. Maybe I'm just troubleshooting bootability in this case. My screenshot failed. I'm trying to figure out why. We can also start systems on their own private subnet behind a firewall either with or without internet connection. I love this as an option. I can use this as a complete sandboxed environment. So I can install Windows updates here. I can blue screen here, and I can do that without lack of fear of breaking anything. So I avoided breaking the production server. And now I can just turn this off and there's no harm or foul done to my virtual machine or to the backup itself. We can also use this in a ransomware scenario. We've identified where we're not encrypted. That doesn't mean we're safe. Let's start the system on the internet, update our virus definitions. Ransomware is usually deployed in one of two fashions. Someone clicks on something and it encrypts everything right then and there, or more commonly, it's downloaded and it's sitting there like a time bomb waiting to go off again. So just because we're not encrypted doesn't mean we're healthy. Original server is encrypted, fine, take that thing offline. Let's boot this guy into our recovery environment, update our virus definitions, clear out our payload completely, take a backup, and now put that live on the network, risk-free. In a ransomware scenario, in a system down scenario, this is literally how long it would take to return to production. And this is the main advantage of Datto technology, of that inverse chain technology. What used to take hours takes about 6 seconds. Virtualization performance is about 4 times greater than Generation 4, and Generation 4 was pretty speedy. Given that we're sitting on all SAS storage, error-correcting RAM, really awesome procs underneath the hood. That system's live on network. Now, granted, it pulled the HCP to avoid an IP conflict. We do have to log in and reassign our original IP address. That's it. Once this is connected to the network, everything would connect here. This would act as the original server, and furthermore, Cirrus would start backing this up, capturing the data changes that are being made here. There's no limitation in time for how long one can run and work on this system. We've heard of people running and working here for months, potentially, and then restoring when it made sense for them. We have a number of different methods of full restoration. I can turn this off, do a bare metal recovery using what I showed you before, the recovery console. That was this page here. That's our bare metal restore. Pretty simple. We load this into a new physical or virtual system, select bare metal restore, log into the Cirrus, select the affected machine. The recovery point is usually the latest one. Partition the machine, review and confirm the data transfer begins. We have a number of different methods of doing this. We can turn off the system and then export a virtual hard drive to a network share USB drive in formats that are compatible with both VMware and Hyper-V. And last but not least, we can also integrate with VMware and Hyper-V to do something incredibly cool here. I mentioned this integration earlier. Now, it's only with VMware that we can integrate and do agentless backups, but with both VMware and Hyper-V, we can act as temporary storage for the virtual environment. So forgive me for 1 second, we're just gonna log into my VMware host. I forgot to do this before. Mind you, we can do the same exact thing with Hyper-V. And let's say we have an environment with multiple host servers. Let's call it 3 host servers. There's 10 virtual machines running on each. We have centralized storage, so about 30 virtual machines running across the network. And the centralized storage just had a significant issue. So we just lost 30 virtual machines. There's no way that we're going to stand up 30 virtual machines on this individual appliance. That's not going to happen. What we can do is integrate with each host so that the CPU and RAM of what you've already invested in becomes available to Cirrus via API. I can see the CPU and RAM here. We're just going to act as temporary storage. And now from a backup, here's the magic. Let's see if I can get over here fast enough to show you what's actually happening. And blow this up a bit. Okay, so in a moment, you're going to see us create a new data store, network data store. There you go. And within a matter of seconds, from backup, we've created a new virtual machine here within VMware. Now with licensed VMware, there are different features that would actually allow us to copy that to another system while it's live and running. It's called storage vMotion. So now we don't need to use Datto recovery utilities. We can just vMotion that back to production. This is all in terms of local failover. I hope I've made it very clear that the solution will provide uptime equivalent to the likes of which we don't really expect within a backup system. If you consider what we have to do with backup, it's usually assess damage, order parts, wait for that stuff to come in, initialize a restore, cross our fingers, hope and pray that it's going to work. This is a much different type of scenario, a lot of peace of mind. I always jokingly say that the employees that work for your organizations are going to hate this system. They're never going to hear that, hey, the server's down, go home for the rest of the day. No, you're working, unfortunately, and you should be up and running within a matter of minutes of that initial failure. More importantly, as we come into the cloud recovery portion, we'll say firstly that the same exact technology lives here in Datto Cloud. Well before disaster strikes, and literally as soon as seeding is complete, we can start testing things. I'm going to start, we'll do 3 different systems in a test virtualization in our cloud. On our own, you or I can only assign 8 CPU cores and 16 gigs of RAM. This is not a true limitation of disaster recovery. It's simply what you or I can assign. In terms of documentation for disaster recovery, I always talk about the pillars of documentation for DR. That's orchestration, who comes online first, domain controllers before file server, so on and so forth. Resource dedication, who's getting what for CPU and RAM. Networking, does everything live on the very same simple network for testing purposes, or do we need to start mimicking and matching your internal network infrastructure? And this can go all the way down to VLANs and that type of thing being mimicked here in Datto Cloud. And then last but not least, the big question is, everyone always wants to know this one, and it's actually relatively simple to answer. How do we get our end users, how do we get our clients connected here? How do they actually run and work in Datto Cloud? And the answer to that is pretty simple. We can back up workstations, so you can just log right into your workstation from here. Or we can back up a terminal server and provide access the very same way that people were accessing the network in the first place if they happen to be working remotely. Last but not least, we also provide open Vpn software. You can have that pre-deployed with a key to connect at the time of disaster, or more commonly these days, head to a new centralized location, and we can enable an IPsec site-to-site tunnel from Datto Cloud to that physical location. We can't become the hub of the network. The new location would have to become the hub, but with a router or firewall capable of connecting IPv1 or IPv2 IPsec, the most secure method. And then in terms of timing, I mentioned less than 24 hours. But just to give you a sense of how long this really takes, I'm creating 3 virtual machines. Oh, what do you know? It's already done. And now we're turning them on. So where we say less than 24 hours to connect here, that typically hovers around, I would say a half an hour to a couple of hours. You'd certainly have a greater sense of this through the course of your own first test. Imagine disaster striking the original environment. Everything's completely destroyed. The Cirrus is gone. And now we have you up and running in our data center. As soon as you're running and working and connecting here, we start taking the backups of the system. Now, there's another major consideration, the time that it would take to transition and get out of here. For those of you that are taking your backups and sending them somewhere else and thinking, okay, I'm safe, I'm healthy in that, there is a major consideration there that a lot of people don't think about. If you experience a site disaster beyond certain thresholds of data, the time that it would take for you to get your data back and initialize restore can still put you out of business. Very scary proposition. You think you're doing what you're supposed to be doing, you can still go out of business because of time, the time that it takes to recover. With us, you're up and running in our cloud in less than 24 hours. We've been told that the original Cirrus was destroyed. Great, we work with your insurance company to replace the unit. We're not going to send you an empty appliance. At a rate of approximately a terabyte per day, a bit better than that, as a matter of fact, with our newer hardware, we're taking all of your cloud data and loading it onto a brand new appliance simultaneously while you run and work off-site. We've overnighted you our new system with the lion's share of your data. Guess what? You don't need to run and work in a VPN tunnel in our cloud anymore. You don't need to run and work in Pennsylvania. We're going to one by one start turning off systems in the cloud, downloading just 24 hours worth of block level change, not the entire data set. That would take forever. And you can picture my talk track here. And the reason that I went through such a descriptive run through of local virtualization, you're going to turn these systems off in the data center and begin running them from here. And then when it makes sense, using the appliance and internal networking to do the full image recovery. So you're not stuck doing full image restore from our cloud. You convert off the appliance, performance is going to go through the roof rather than running in a VPN. There's no limitation on how long you can run here. And technically, there's really no limitation for how long you can run in our cloud either. I want to be very clear in that. Within fair use policies, right? You can't just leave your network up and running in our cloud, but trust me, you will not want to if this ever happens. I hope no one ever has to deal with something like this, but you will want to run those systems locally and recover them from here. Brittany, that's about it. for my side of the presentation, I hope this was a good use of everyone's time this afternoon. Certainly, we could have more detailed discussions with the folks that were on air here with us.
Yeah, absolutely. And we'll be recording this, so we'll be sharing it with everybody as well. We'll give everybody another minute or two to put in any questions that they have. But again, we thank you guys for joining us. Dan, that was absolutely incredible. The team at Datto is always there for us, and we're always there for you guys. We work really hard. We've got a dedicated team that is looking at everybody's backups. On a daily basis, they go through and check everything, and then if they get any alerts, they're immediately checking that. I think right now, I'm just going to look at our data. We have 48 clients on Datto servers. We have 534 current servers on Datto, and then over 350 terabytes of protected data on Datto. So if you guys need any assistance, don't hesitate to contact us. Datto is one of our only disaster recovery functions that we use. And that's one of the reasons why we're a Datto Diamond partner, because they are here for us and we are there for them. Well, I still don't see any questions yet. Give everybody back a few more minutes of their day if there isn't anything. Dan, did you have anything you wanted to wrap up?
Just to say that, again, I'll reiterate that I never really liked this technology prior to starting to see what we were capable of doing here. It's very, very different. It's a different approach. I think that it needed to happen. Backup was so similar for about 30 to 40 years, and there were no innovations here. So this is a new animal. It's a different way of approaching things, and there's nothing like staying out in front of your problems. Don't sit there and cross your fingers and hope that things are going to to work, because they usually don't. But yeah, from our perspective, our support's 24/7 behind this wonderful team here. We specialize in this. We also have this really cool humanitarian type of effort where if we notice that something large is going to happen in Florida, let's say, if we see a gigantic hurricane approaching that area, Datto actually sends a crew of people to work with the local MSP. I think we may have done this with you guys before, actually, Brittany.
Yes,
And
we've actually had some government clients that have been down that we have gone in and got them back up and running within hours, which is
right?
huge for some of our city and county governments that they need to have access to all of their information to make
How cool
sure
is
that all
that?
their customers out there are being assisted. So
Very different type of vendor partner relationship when you can say to people, hey, look, here, come work from here, right? It's not just hawking hardware at people and saying, hey, good luck. No, we're here. It's a collaborative effort, and it's very cool to be a part of it.
yeah, absolutely. Well, thank you again, Dan, and we'll give everybody back 6 more minutes of their day.
Perfect.
Thank you
Thank
very
you, Brittany.
much.
Take care.
Bye-bye.